Okay. Good afternoon, everyone. You are all welcome. Basically, the purpose of this training is to introduce ourselves and then to make ourselves a network security engineer. And then we have our agendas boldly written down here. If you can, okay, let me share this other screen now. Okay, if you can see this other screen, let me know. Theories and labs. So now this is the agenda. This is all the route we are going to follow step by step. Technically, I summarized them into 1, 2, 3, 4, 5, just 5. This is your recommendation, 5. There are more than that. There will be a subset as we go, but this is what that comes to my mind now because I don't really have any documents for this training per se than, okay, apart from what I know. And then as we move on, I will be adding more information as it comes to my mind so that we can have the whole understanding. Having said that, the whole thing we need to do to make ourselves employable is all this. It's no more than this. Knowing the networking fundamentals, understanding the OS. OS means operation system in Windows and Linux. We'll do some basic operation system configuration of Windows and a basic operation of Linux. And then from there, we go to other configurations like VLANs, routing protocols. We go to firewalls, so like I said, I'll be adding as comes to my mind. Like now, after VLANs, we go to LAN, and WAN. All these terminologies, don't bother yourself if you don't know much about them or if you don't know anything about them, and then they don't worth memorizing. Don't bother to memorize them. They will come to you naturally as we move on. So having said that, the only documentation that I see that is very, very useful for now as we go is this. Where is it? Is this, can you see what is networking?
Yes.
Okay, cool. So this documentation, I session line, I've gotten it for some time now, but this documentation is very, very good from my own perspective. It covers everything we need to know about networking on a basic level. So if you look at it, the question says, what is networking? There's no general term or one specific definition for networking. And they don't need to be, it's not an academic environment that you need to memorize the definition. You just need to know it. That is how we go to, that's the method we'll be using. If you don't know it, ask a question, but the bottom line is just to know it. Oh, this is this, and then you move on. Okay, let me mute everyone. I'm going to mute everyone, and then if you have questions, you can send it to the chat to avoid distractions. So, like I said, everything we'll be doing is not to memorize anything, please. Even the configuration, you don't need to memorize it. What we need to do is just to document. Everything you need or you consider is useful to yourself, document it. And then another valuable recommendation or suggestion is every thing I'll be saying or I said, please jot it down and then make more research on it. The small information may not be enough. And then the recommended book for this training is this. If you can lay your hands on it, or whether hard copy or soft copy, good. CCNA certification book. This particular one by Lambide. The author is Lambide or Lambide or something like that. Okay, to the Lamley. If you can get your hands on this, it's very good. Not this practice, it's 2 in 1, but you can get only 1. But what I'm saying is, okay, this particular one, okay, let me go to this one. This one. Okay, this is just a guide. I'm just trying to get particular one that's study guide. This is 2 in 1 study guide with online lab. Okay, let me check this one. Okay, this one, don't buy this one. No, this one is very expensive. Don't buy with this price. That's what I mean. But if you can lay your hands on these materials, either from anywhere, it can be from Thrift Shop, it can be from anywhere. You can get it less than $10. You can get it on eBay. Anywhere you can get it. But don't buy very expensive one. You can get it $4, $5, $10, as case may be. But just try to get one, just to support yourself, and then to serve as a reference materials. So having said that, this is one. And then if you look at the agenda that I posted before, the agenda contains not only the networking part of it, it contains security. So knowing our destination is security, but one cannot be a good security without knowing networking. So, because you cannot secure what you don't know. That's why it is expected to understand all these fundamentals. These fundamentals will help on the long run, because our day-to-day activities is just what you are seeing on the screen. Nothing more, nothing less. They may be sounding on high level, but when you join a meeting in your working environment, this is what we'll be discussing about. They'll be talking about routers, they'll be talking about server, they'll be talking about end client, they'll be talking about firewalls, they'll be talking about internet. All these things, or all these devices, they have other names they call them. They have the layers, the functions. So by and large, understanding them is key. Understanding them is key. And then, like I said before, none of this definition worth memorizing, because there will be a lot to memorize if you want to go that route. But knowing them is just it. And then our concepts, it will be on hands-on. We do a little bit of theory, and then we go to the hands-on. How does it work? And then I know majority of us, we are let me say, we are from Nigeria. We shouldn't have this mindset of knowing it all. You don't need to know everything all. You don't need to be a master of all before you start testing the water. Testing the water is applying for jobs, getting your resume. Don't say, I need to read all these books. I need to get this one done. No. Nobody's a professional on everything. It's a work in everybody's a work in progress. But we have that mindset. So I need to learn this one quickly and I move on. But if you want to wait until you know everything, you will wait and wait because there's more than enough to learn. But when you learn, like me now, I want to be a very unique in my approach to this, sharing my information with people. I want to share what is valuable to learn, what we need to get job done, not knowing everything in the world or in the world of networking or know everything in the world of security. I can quote you or quote me anywhere. Nobody, even if somebody has been working for more than 20, 30 years in the industry, they cannot celebrate that they know everything in security. Nobody does. If you know security, it can be a security engineer in endpoint. It can be a security in the server. It can be email security engineer. It can be network security. Being a network security engineer, your action or your duties just entails on firewall. You're working on only in the firewall. But if your job entails working on endpoint security, you'll be working on small devices like laptops, mobile phones, IoTs, you'll be working on router, a little bit of routers. So that is all about what our agenda will cover. For the purpose of people that just joined, this is our route. Anytime you cannot see new page I paste or you don't see what I'm talking about, you can send information on the chat. I will quickly address that. So now I'm showing a page showing theories and labs, networking fundamentals, OS, Windows, and Linux, and some other stuff here. So somebody may ask, oh, how long will all this take before we can start applying for jobs? People that we started together last week, I mentioned that, oh, my plan is to cover all the networking part this month. And then next month, this month is today. No. When I mean this month, I'm thinking, okay, November, and then December, we cover the net security part of it. And then from January, hopefully, if everybody on the same speed with me, we start applying for jobs. We start looking at our resumes because, like I said last week, January is it's always very busy. It's always very busy for companies to look for new employees. There will be a lot of new openings here and there. And then even from December, because the peak will start from November, December, January. So at the end of January, it will deep dive, it will nosedive a little bit, it will rise back maybe towards the beginning of April. At every quarter of the year, it's always rise and fall. So this is my own plan. This is the agenda that I have for this class, that, okay, let's cover all these major areas that I know that based on my own experience, based on how many interviews I've done, all the questions they always ask is centered around everything I wrote here. Though some of these, they have definition. They have some protocols in between them, but this is the fundamentals, and then we cover all. So let's go quickly to this one I was talking about before, the networking. We all know networking, but we don't put it into perspective of definition, because once you have your phone, you have your laptop, you have your modem in your house, you have network. But the question will not strike your mind, say, oh, wait, is this kind of network we're talking about in enterprise level? The answer is no. In enterprise level, there's a different ball game. Why? In enterprise level, we don't use modem, we use routers. In enterprise level, we use Wi-Fi, but we don't use Wi-Fi like the one you have in your homes. We are using switches. The switches will now be the point of disseminating the traffic to other endpoints, like Wi-Fi, like clients, like printers, like many other plethora IoTs. It depends on your organization. And then most of the things that are common in enterprise level are just servers and endpoints. When I mention endpoint here, I mention your laptops, your workstations, because if you can see my screen, you see some connections in between those devices. Those cables connected them together. They have point called RJ45. They connect them, but there's another link. If you're looking from the left-hand side, you see something at the side, at the center, like green, light green, yes. That one is switch. There's a switch there. There's a router. We'll cover all those, but I'm just giving the basic. So the network, the laptop or your endpoint or your workstation, they use different name to qualify one thing. So we'll be using endpoints. And then we mention endpoints, you know that I'm talking about laptop, I'm talking about workstation, I'm talking about IoTs in the organization. So the endpoint will connect to this switch. Switch will connect to the router, and the router will connect to the firewall. Firewall will connect to the internet. That is the basic design of every organization. There's no two ways about that. There's no other way. However, we have what they call flat network design. We go all those routes when we are doing our lab. When you have a flat network, you don't have DMZ. It's just from inside to outside. And then we have north-south, and then east-west traffic. So all those terminology I mentioned, don't bother yourself if you don't get it. But when we move forward, you will know everything you need to get the job done. So having said all that, it's just to portray that we don't need to memorize anything than to know how a network works. So according to this definition now, say what is networking? The networking is a group of computers that use common communication protocols. So to me, I may not go with this definition, but it's okay. But like I said, we don't need to memorize it. Network, from my own perspective, means making two computers communicate. If you can make two computers to communicate together, you have done a network. How? The bottom line of our job is to make sure that there's a transmission of data from one point to another point securely. That is where we come in. Because two computers can communicate without securing them. An hacker can be in between or man in the middle, can be in between. If you are doing an important transaction online, all your information are on plain text. When I mention plain text, means that it's not secure, it's not encrypted. When it's not encrypted, anybody can sniff it. If I forget, somebody can remind me to talk much about packet sniffer, because when you know much about packet sniffer, you stand out from the crowd. When they ask you in an interview, how can you why are you protecting your network? You must know why of almost everything. Why this, why that? Because when you know why, you know you will now value what you're doing. If you don't know why, you just be like the other guy. Who's the other guy? Everybody. So, but when you know why, you are taking informed decision. So now, why are we securing our network? Is to protect our valuable data. Anytime you go to ATM to take money, to withdraw money, immediately you slot in your ATM card, all your information pass through from that ATM to another server somewhere. The information is not on that, is not stored on that ATM. The ATM machine just serves as a reader, as a storage of money. But the authentication and then the accounting purposes takes place somewhere else. They have a server. That's why we'll be talking about data centers. Those are ones are stored somewhere else. So now, if there's no security in line, immediately you slot in your card, somebody seated close to the bank can use what they call packet analyzer and analyze your transaction, because you may just imagine, say, this is very quick. The same thing, we have some very quick machine that can diagnose everything. They call it in milliseconds. So those milliseconds, as you are slotting it in, the information is changing from the client to the server. Somebody is sitting down in between and then analyzing those packets as well, getting your IDs, your card information, getting your password, getting your username, even getting your account number. Everything will be in his laptop, because at that point, we are assuming that there's no firewall. But if there's a firewall in between, once you slot in your card, the message is, the authentication is sent to the server. There will be, both sides will be encrypted, because there will be a TCP three-way handshake in between. When the three-way handshake completed, the firewall will make sure that the message is protected. So that is one of the whys we are doing what we're doing. We protect PII, that is personal identifiable information. We protect data, organizational data. We protected bank information. So that is that. And then we cannot get those things done without all these devices. The major device here is router from internet. And then you may be curious to think, okay, why router? Why internet? Everything's just here on their own. Yes, this device just symbolizes how a real network is. In every point, there are other things that go behind the scene. Like the internet, we have ISP. They have their own job separately. The router needs to be configured to allow certain things to take place. The firewall needs to block certain URL, certain traffic. So everything you are seeing from this screen, they have specific actions they carry out to make things work. But important thing is they are on a network. They are on a network that make changing or exchanging of data take place. So if you go to your house or after a while we close this meeting, you ask yourself again, what is network? The network is a network is connecting two devices together to exchange data. Finish. But when you're talking about security aspect of it, is exchanging data on a network securely. Period. If you go online, if you type those messages online right now, check them. It may be a long definition that look convincing, that looks very confused, but there must be a secure information there. So that is just, so now I believe we all have understanding of networking now. I've not gone to the area of talking about what each and every device does right now, but I've just been able to pinpoint what is networking, why we are doing what we're doing, what are the major devices that needs to be on the network. So we unmute us now. If we have any question, quickly, let's ask, or I'll just move on. So you can unmute yourself if you have any question. If not, let me just see online that on the chat that we should move on. So if you have any question, let's ask. Okay, I believe there's no question. I'll need to unmute everyone again. I need to mute everyone again. Okay, now we have overview of how network, what is network, what are the little things or major things that made up a network. Now, another area we need to take a look at is type of networking. And then please, everything I say here now, don't just take it, don't take it for, say, okay, I've gotten this. No, you can type all this information online, make more research on them, read extensively on them, keep any data you get for yourself and form your own notes. That it will be very helpful. So let's move on. So now, types of networking. Majorly, if you ask ourselves, what are types of networking? From professional perspective, I would just say we have just two types of networking. We have LAN and WAN. If you look at here, this one is here. That's LAN. This is WAN. All these other one, just ignore them. You know why? They are not relevant. Just to make the book full. Local area network. An example of local area network is your house. From the low level definition. Now, in your house, if you look at your modem, you see a wire or a cable that comes from the body of your house connected to your modem. And then from your modem, you can get a Wi-Fi connectivity. That is a LAN. From enterprise definition, it's the same thing. How? We have a nice, maybe now, let me use this scenario. You have your own business and you have 5 employees. And then each of your employees have their laptops. in your office. So each of those laptops, they need to connect to something that will give them access to the network. That's switch. So we connect all the laptop with RJ45 cable to the switch. Let me show you the image of the switch quickly. Where's that file materials? Can you see this? Can you see this one? If you can't see it, just chat on the chat, send the chat, send the message on the chat. Okay, now if you can see this my screen, there's 4 ports. This is what we call interface. It is for every device you see on the internet. That port, the size of the cable that goes there is what they call RJ45. If you type online, check RJ45 cable, you see this design like this here. So now you connect a cable to this based on your router or your modem from ISP. You connect it to this one. This one will give access to all the laptops in your organization or your office. We are talking about small home office where we have 5 employees. This is a LAN. But here, the guy is talking about wireless local area. There's nothing like this. Personal local area, they are talking about your home. All this one is just mere definition. It doesn't make any sense. So, but this one make a lot of sense. Local area network is your own office network where you can control, where you can assign either static IP or dynamic IP to. That is your local area network. On the other way around, and if you look at the picture, let me make this one bold a little bit. If you look at the picture, you see that every device here, I'm talking about this particular one, local area network. Please, if you don't get me or you don't understand what I'm saying, you can send a message to the chat so I can say it again, or I change the pattern. If you don't understand the way I pronounce things, let me know. So now, if you look at, because we learn from different perspectives. Some people learn virtually, some people learn through audio, but a lot of people learn, a lot of engineers or people that have artistic traits, they learn through visual. So when you visualize things, I've seen this before. So now, if you look at this picture, you see that the connectivity is from different things here, and they don't mix it together, please. We are not talking about your house. We are talking about enterprise network. An enterprise network, you see that there's a switch. If it's your house, you don't need your modem or your router to connect to a switch. It will connect straight to the ISP. ISP is internet service provider, like AT&T, Comcast, name it. There are many. If you check online, there are many, but those are the major ones we know. There are many. There are plethora of them on the internet. So now, look at the laptop, connect LAN cable, you connect to the switch. Another computer connect to the switch. Another computer connected. So they all connect to the cable. Even the printer connect to the switch. They cannot get any access to network without connecting to the switch. Now the switch will connect to something else. All these things you are saying, we are going to do them on lab, which will play how they work, how things work in enterprise level. And then one of the problems we or some of us may end up get is doubting. If you have doubts in your mind, anything, don't just do it. What I mean by doubting is I'll be saying everything raw here. And then if you have a doubt in your mind, there's no way, there's no remedy for me to that kind of issue. What I mean by that is everything we'll be doing on lab, that is what is applicable on the job. Let me repeat that size. Everything we'll be doing on lab, we'll be doing lab on, is applicable on job scenario, is applicable to any working environment. When it comes to networking and security, it's not a guesswork, it's not assumption. That is what is going to take place. That's how it works. For example, now let me quickly go here. If you go to your computer, just type CMD, you see something command prompt come up. So now, if you see the command prompt, if you type ipconfig, if you type ipconfig lowercase, ipconfig, because we have started deep diving with that. So now you see a lot of stuff coming up. Some of us understand this, some may not, but you see something like IP address, something like MAC address. It is like that in everywhere you go when it's come to Windows computers. This is a Windows operation system. So now, if we can do it and we get results, yeah, if you do it anywhere, you get the same result, because the computer environment or networking and security is a scientific base or computer mathematical base. What I mean is 2 plus 2 here is 2 plus, if it's equal to 4 from our side, it's equal to 4 anywhere. The same way we configure a switch here in the States, that's the same way they do it in Africa. That's the same way they do it in anywhere in the world. It's not that, oh, this is our own passion. No. However, we may have different vendors. Different vendors may have different configurations, but the principle, the fundamentals of everything still remain the same. A switch is a switch anywhere. A router is a router anywhere. A firewall is a firewall anywhere. So that is one of the reasons why learning this thing, knowing it's very easy. It's not that, oh, every environment have unique stuff that you need to learn in very unique way. No. Once you know the fundamentals, the quick or the better analogy is driving a car. If you can drive a car, even whether you learn in Africa, you learn in Europe, where you learn doesn't matter. Okay, can you drive a car? Yes, I can. Okay, I want you to drive car in the States. You know that steering is steering, every other thing remains the same. What is now different, which is applicable to enterprise level, is the policy, the rules and regulation of different jurisdictions, different countries, different countries. You now abide by that. But the driving of cars is the same thing. Even if you need to drive a trailer, you don't need small training. You don't need to learn the basic no more. So all this one we are doing now, we are learning the basics. We are learning the fundamentals. So it's applicable to everything on internet. So I've said that. So that is network, that is local area network. So when we go to the other types of networking, which is one. If I'm too fast, let me know. If I'm too slow, let me know. Oh, Mr. Ibro. So now we are going to talk about the other part of network, which is wide area network. The wide area network is the opposite of the LAN. Just knowing that way. All this one metropolitan area network, campus area network, we don't really need it, but you can reach on it on your own. But the major one we need, like I said, we just need to go straight to what we need to get job done. All this one, metropolitan, is like making two campuses together. Campus is majorly used in universities and the like. But we are talking about enterprise level. So now, wide area network. Another name for wide area network that we should need to know is internet. Anytime you hear about one, just remember internet. Simple. Because we just need to make life simple for ourselves. We don't need complex definition story. So we need simple definition. This is wide area network equal to internet. Boom. And then what makes up internet is different routers. Different ISP come together to form a wide area network. That is why they call it wide area network. See now, we are in Atlanta here. Maybe we have Comcast dominated this environment. In another environment, they may not be Comcast, maybe another ISP, but they come together, they understand themselves. Okay, if my client is in Georgia, what can I do to make it have access to my network? Okay, you pay me such amount, or bring your server, or bring your router on top of my IDs, or you bring your mass, match it on top of my mass, you pay me monthly. Okay, cool. Or we can synchronize, or we can share our bills, so that when you, as a AT&T client, go to UK, and then another ISP in UK, their client come to US, if I'm rendering a service to him or her, I pay you, you pay me, or we just swap services. That is majorly how internet providers share the compromise things, or the understanding. So that is just a basic overview. If you want to go to service provider line, that's another route, but you just need to know all this, because every environment in networking security, they have domain you can specialize. So there's no much to talk about that again than to say, okay, wide area network is internet, and then the local area network is just like your home house or small office that you have for yourself. So that is that. So this one is in enterprise network. All this one, there's nothing like that. All this one, storage area, and all this one, storage. Okay, another area we can quickly take a look at is this is not type of network. Because this PDF, I just downloaded it from internet, but I see it's very useful, it's very good. Some of the information we need to move on with is there. So I will send this to the group chat, and then if you can read it, you are not making any wrong mistake. You can read it, and you can still read. So Wikipedia is your friend, Google is our friend, YouTube is our friend. So those two materials, they are more than enough. Google and YouTube, they are more than enough. Like what we are doing now is just to connect the dots. You can watch the whole YouTube video, you will not, it may not end up not learn nothing. But when you have somebody who can connect the dots, this is why this, because what we need is why we are doing what we're doing, and then we are making decisions. So now this one is not a type of network. This is just VPN. We'll talk about this one later. So quickly, I will go into this one, but we may not finish it today because it is very broad, but I will quickly go into it, and then please read more about it. That is why I said this information, this material is very good. Where I was trained, they just use name. They present all this to us. We were not given a kind of well-presented documentation like this. So this one, to be candid, if it's only this one you really know very well, you can defend it, you are good to go. You are good to go, I mean, is at least you can get a job, but you can, I mean, not able of getting the job done if you don't know the lab part of it, because the lab part of it is the key. We need to do the lab. We need to connect those things, and then we see how these layers work together. This one is called OSI model. I don't need to define it or start reading the definition. We just need to tell ourselves what it means. The OSI model, as the name implies, is just a model. A model means a kind of guide or a virtual guide. It's not exist. It's not exist. It's like having something you refer to when you want to do certain things. Can we call it like a, no, that is not like a roadmap, but it's like a blueprint of networking. Yeah, it's like a blueprint or how certain protocols will work behind the scene. So if you look at the definition, it is open system interconnection model. It's a contextual model. Contextual means it's just conceptualized. The concept is not real. So now they create it to make a reference that, okay, for engineers to know what they are doing or to refer to communicate. Basically, it's just for communication. Most of the meeting I've attended, many engineers, they will just be referring to, oh, it's a layer 3 issue, it's a layer 4 issue, it's a layer 2 issue. Just fanciful word they'll be using. So now we coming in, we need to know, oh, what are those things in layer 2 or layer 3 or whatever. So OSI model is just a conceptual reference guide to know how underlay protocols, underlay definition of internet, of operation system work. If you look at it, don't look at it from one perspective. Look at it from the perspective of two devices. One in the right, one in the left. Anytime one is, if you are going to, if you are browsing now, if you type anything, there will be an underlying protocol working with your computer and a server. From that layer 7 to layer 1, and from layer 1 to layer 7 of the server. Because one will be encapsulating, one will be decapsulating it. Because if they cannot do that, you won't be able to access whatever you want to access online. So the physical layer is the way we connect our cable. That's what I was talking about, cable the other time, that we have RJ45 endpoint that will connect to the, either to the switch, and then from the switch to the router, from the router to the firewall, from the firewall direct to the ISP router. That is how it goes. So if it is a problem on that layer 1, maybe the connection is not right, or the cable has problem, we call it layer 1 problem. And then if you read it, you see that it's physical structure, because that one is physical. But on the layer 2, which is data link, and the only thing I would love us to have at the back of our mind or to memorize is just from layer 2, layer 3, and then layer 4, what they process, their end results. Like now, layer 2 is frames, layer 3 is packets, and then layer 4 is endpoint to endpoint connections. We're talking about TCP and UDP. As time goes on, that's why I say this one is very small, but it's very, very complex. Knowing it is very, very good. You can take, it's not what you learn and abandon. You can be reading it all the time, every time, all the time. You get yourself familiar with it, because almost all the protocols works. All the protocols, not almost, all the protocols work on different layers, which we will talk a little bit about them. So layer 2 is frame, that is data link. On layer 2, there are some stuff we have not said anything about, like MAC address, like IP address. We'll talk about them as time comes. So, but now, this is the way these guys arrange this documentation, which is fantastic. So layer 2 is MAC address. A MAC address is called physical address of every device. That is why nobody can do anything online and walk away. If you have not been caught, your time is numbered, because the MAC address has unique identifier of the buyer and the seller. And when I mean the buyer, you. When I mean the seller, I mean the manufacturer. That is why anytime you go to Best Buy to buy anything, they take all your information. And then that information is given to you, that device is given to you, and the record is being kept. So now, if your device commit any error, they will contact the manufacturer will contact the supplier will give your information to them that, oh, this is the guy we sold this information to, this device to, they meet you. So you see, there's nothing lost, because every device has what they call NIC, network interface card. Network interface card is a soldered package on every motherboard. You see, I don't want to go to elementary of computer, like, I don't know, but if you need to know basic computer package, let me know. Maybe you can go that route first, because we have not said anything about USB, RAM, CPU, all that. So I assume that, okay, we are in the middle, we have basic understanding of computer. So now that particular NIC, there is a NIC number on all of them. It's like a VIN number of a vehicle. So let me use that as an analogy. It's like a VIN number. So your VIN number will be identified by the manufacturer, by you that bought it, and nothing lost. So on the network side, what we use by switch, because switch is the layer 2 device. So what you use to identify the package coming is the MAC address. That is layer 2. So anytime you hear somebody is talking about layer 2 problem or layer 2 device, is switch. Okay, we'll quickly move away from there. We go to layer 3. On a layer 3, as the name suggests, is the third network device, which is router. Is the one that decides where to route a packet to. You know, we have not said anything about routing protocol and all that, but at least let's have a basic understanding of it now. So now, on every network, there's a router that will route the packet from the source to destination, either to this destination direct or to the gateways. And then what does route really do? Router route package and forward it to the next hub if they are on the same protocol, if they have everything be equal. So on layer 3, what it sends out is packet. And then don't forget, when I mentioned from layer 7 to layer 1 the other time, I mentioned something, encapsulation and decapsulation. So encapsulation of packets start from layer 7 downward, and then those packets contains a lot of stuff, like it contains the payload, it contains payload, the IP header, and some other stuff. We don't need to know all the scientific nature of everything, but at least we have the basic. So now the payload the data, the IP header, those payloads is part of the packets, the IP, the ISMP, IPsec, or some other protocols. So the layer 3, what really carries out that function is router, and what router sends is packets. Please don't forget that one. We have mentioned about frames, which is switch. We have mentioned about packets now, which is router. But on layer 4, there are some other devices that work on layer 4 and up. And then some people will tell you, oh, we engineer, we just need to know about from layer 1 to layer 4. That is wrong. It was right before, but now it's wrong now, because now the firewall works from layer 7 to layer 1. Some will say, oh, it's work from layer 7 to layer 2. Anybody can be correct, but to me, it works from layer 7 to layer 1, because even firewall, you need to do the physical connection. And firewall works in layer 2. It can work as a switch. Firewall work as a router. It can work as a router. Firewall working on layer 4, which that it works on TCP and UDP protocols. So on layer 4, what works there is majorly firewall. Routers can decode TCP, UDP, fine, but on that transport is two major protocol we only talk about when you mention layer 7 OSI model. We mentioned about TCP and UDP. Those are the transport. As name suggests, what they do is they transport traffic from one end point to another endpoint. TCP is transport control protocol. Transmission control protocol. That is what it does. It's a reliable protocol that transports package or packet to another endpoint. Transmission control protocol is very reliable. Why we say it's very reliable, because so that's why I said we don't need to know why of everything. How? Why is it reliable? Is if there's a problem now, it sends a packet from one PC to another PC, but the packet along the line, it missed some aspect, some data loss. It will retransmit it. It will do what? It will do TCP retransmission. That is why they call it reliable. One, UDP. UDP is user datagram protocol. User datagram protocol. This one, if you are hearing me now, we are using UDP. Whether you are hearing me or not, I'll be saying what I'm saying. That is UDP for you. That is the protocol we use, that is used there. So it is not you that made the decision of what to use. On enterprise level, you can manipulate it. You can design your application to work on certain protocol. But I don't want to bother you with a lot of information on that now. But on a basic level, if you are watching a YouTube video, you are using UDP. If you are, as we are on this Zoom, you are using UDP. The UDP is not reliable. It will transmit the packet, it will transmit the message, but it doesn't care whether you hear or you don't hear, whether you go to the server or not, to the client or not, it will deliver. That is UDP for you. That is transport layer on layer 4. And then other one is session layer, presentation layer, and application layer. Session layer, what it does is sync the ports, and then some other package on layer 7. That is, it keep the session. Okay, maybe I'll keep those one to the when we're talking about firewall, because it's the only way it can make more sense. A firewall keeps session on the session table. That's why a firewall is called what is it called now? Okay, maybe when I remember, okay. It's intelligent, and then it keeps the session on the session table, and then when the session ends, it will flush out the session table before another one comes. So that is it. And then presentation, we have all these protocols. We just talk about protocols that work on layer 6, but you don't need to memorize all this, please. Just need to know what you even need to know is just from layer 1 to layer 4, what's the end result. The end result I mean is the physical structure. Okay, the physical layer 1 is just for physical. Layer 2 is for MAC address. Layer 3 is for IP address and routers. Layer 4, which is transport layer, is TCP and UDP. And then layer 5, 6, 7, they are majorly for application, presentation, and session. All this one, we discuss majority of them when we're doing firewall, because we need to see them how they role play. That is that. This is another TCP/IP model. They condense this 4 layer to 4. This is where it makes a little bit sense. This is according to some people, they said this is the one that we are using in the working environment, this particular one. How? If you look at when I mentioned this side, if you look at it, you see that the layer 5, 6, 7 doesn't make any more sense, but they condense it to 4 here. They make layer 1 and 2 as 1, layer 2, yes, layer 3 as 1, layer 4 is on its own. So they condense 3 steps to make it 4 layers. This is TCP/IP. However, okay, which one do we need to know very well? Please know both of them. How? If you are doing interview, this is what we use. But if you are working, this is what we'll be using majorly. This is what you'll be using both of them when you are working, but any which way, just know both of them. Because I don't see any difference there, but most of the time when you are talking, maybe you are doing an interview, you say, oh, okay, what can you tell me about OSI model? So from layer 1 to layer 7, this is what they always ask about. So know this one. TCP/IP, to me, it's the same thing, because when you mention network access layer, this is a physical layer. This physical layer is the one that comprises of what? Of the layer 1, layer 2. And if you look at internet layer, this internet layer is what? It has a layer 3, which is made up of packets. This is where the packets it sends. The transport layer is made up of, that is, another one is layer 4, which is made up of TCP and UDP protocols. So now that is that, but knowing it is not bad, but this is the one they always use for interview. If I don't make mistake, we have this is 1 o'clock now, and then we'll talk about this one next time. We'll talk about common protocols. Let's call it a day here. Let me stop the record.